Today we're going to be leaving the standard lessons in the textbook to do AL2, Alabama Lesson 2, covering stem and leaf plots, because apparently stem and leaf plots are not on the national course of study, but the state of Alabama says you need it. They did not give us any information like pacing guides and whatnot, but just looking at it, there's only 7 resources here, so I think this one's going to blow through pretty quick. Many larger cities have subways that use people for mass transit. The table shows the ages of the people in one car of a subway. So you can see all the different people in this car. There's a total of 3 by 5, which is 15 people in the subway car. And of those 15 people, the ages of each one is listed, with the youngest being 7, the oldest being 62. What could be a statistical question that you could ask about this data? Well, you could ask the range. You could ask what age group was most present, which decade of age group is most present, something like that. You could ask which decade is least present, and are there any gaps in the data set? These are all some good questions that you could end up asking about the data that's here, and a stem and leaf plot is a really good way to organize that data in order to see what things actually look like. We're going to pick up a number of new vocabulary terms in this lesson, the first of which is stem and leaf plot, and it says that you can use a stem and leaf plot to organize large data sets so that they are easier to interpret. In a stem and leaf plot, the data are ordered from the least to the greatest and organized by place value. Now, I've also seen stem and leaf plots that are organized from the greatest to the least, up and down. We'll talk about it, don't stress it, but it's always least to the greatest on the left and right side. So here we have a list of a chart that shows the number of texts in each day by different people, or maybe it's a whole bunch of days by one person. I'm sitting here just looking at the data, and I'm betting that person, that's probably going to be a teenager, although that number probably needs to add a 0 or 2 behind it. And this is going to be some old fogey like me. I text my wife, occasionally I text my kids, but I just don't have that many people I care to text. They want us to represent the data from the table into a stem and leaf plot, and we're going to learn how to do that in this lesson, or this slide set. The first thing we're going to need to do is we're going to need to figure out our least number and our greatest number. So you can see that the least number is 2 and the greatest number is 45, and because of that we're going to be taking and moving. Let's see if it'll let me highlight that. Doesn't look like it will. We're going to be moving from 0, because 2 is in the 0, 2 section, all the way up to 4 in our stem and leaf plot. The stem is going to be your tens space, and the leaf, it's going to end up being your ones place. From there, the next thing they're going to do is you're going to take and pull through and add the numbers. Now, where did they get those numbers from? They got those numbers from this chart. So, for example, 35, they would take, or I would honestly, when I'm doing this, I start with my least number, which is 2. So I'd get the 2, I'd put a line through it, and then I'd write the 2 right here. And then let's just go ahead and do that. Hold on. Alright, so I'm working with my data set. I'm going to take and start with my least number. My least number here is going to be a 2. So I'm going to take the 2, put a line through it, and I have 0.02 right there. I'm going to put down a comma. My next smallest number is going to be a 3. Put a line through it and put my 3 here. My next smallest number is going to be a 5. Put my 5 here, and then I have a 7, which I'm going to put my 7 here. And that's everything from my 1 through 9 section. Now I'm on my 10 through 19 section of my stem and leaf plot, and the first number I see is going to be a 10, so I'm going to put down a 0. And then after the 10, the next number I see is going to be a 12, which I'm going to put down a 2. And then I have a 14, so I'm going to put down a 4. And I have a 17, so I'm going to put down a 7. And I believe that is everything in my 10 through 19. Now I'm moving on to the 20 through 29s. So I've got a 20, so I'm going to put down a 0. And make sure you understand how this works. I have 2, 0 is 20, 1, 2 is 12, 1, 4 is 14, 1, 7 is going to be 17. You see how it works? And going back to my 20s range, I had a 20. I've got two 21s here and here. I'll put 1 1 and 2 1s. And then the next one, oh, I have 3 21s. There's another one right there. And then the next 20 thing I have is going to be a 24, I believe. There's my 24. And then I have a 25, goes right here. I have a 27, goes right here. And I have another 27, which goes right here. So currently the 20s are my largest number group that I have. Next, I'm going to move into the 30s range. And for the 30s range, I've got a 31 right here I'm going to mark out. And then I have a 32 right here I'm going to knock out. I have a 33 right here I'm going to knock out. And I have a 35 right here I'm going to knock out. And then that old person that's on the car, 45 is really not that old. It's going to be 45, or I'm sorry, we're not in the car, we're texting. That day when there was 45 texts right there. And that is going to be your completed stem and leaf plot. Now, I'm not sure if the textbook's going to require it, but I do expect you to also put in a key. So my key is going to say this: 4 bar 5 is equal to 45. You can see right here, 4 bar 5. You can use any number on the stem and leaf plot. Doesn't have to be the last one. 4 bar 5 equals 45. 4 bar 5 equals 45. And the reason that key is important is I could do something like this. 4 bar 5 is equal to 4.5, which would totally change everything, because then I'd have 3.1, 3.2, 3.3, and so on. But that does not really apply to the problem we're working right here. Now, jumping back over to the textbook with their finished stem and leaf plot, you do see that down here in the very bottom, they did include their key that said 2 bar 7 equaled 27 messages. They did include a key, and they ended up using this value for 2 and this value for 7 right here. So 2 bar 7 equaled 27. You can use any numbers you want in the key as long as those numbers are located on your stem and leaf plot. Now, question, what happens if we didn't have any 30s? Even if we didn't have any 30s, you still have to have a 3 sitting right here as a placeholder. You could have it empty on the right-hand side, but you still have to have the 3 as a placeholder because we still needed to have that 1 for the 45s put out there. And at that point, the 45 would be what we would call an outlier of our data set because it was really far from everything else. Now, the stem and leaf plot is useful for looking at your data and seeing what you have. For example, look at the data real quick. What's your least number? Your least number is 2, right up here, 0, 2. What's your greatest number? 45, 45. Which one is your mode, meaning it occurs the most? And that's going to be 21. Right here, you got those 3 1s together. And then which age group happens the most often? Well, the 20s seems to be the ones traveling in that subway more often than anybody else. And then if you wanted to know what the range was, the range would be the 45 minus 2, which means there's a 43-year gap between the youngest person on that, or the fewest number of texts, and the most number of texts. I keep thinking we're doing with the subway car again. Now it's going to be your turn. Pause this video and work this problem on your own. How did it go for you? Let's see what I'm going to do. I'm going to start off looking for my least number. My least number is going to be 10. My greatest number is going to be 40. Looks like, nope, 44. So I'm going to have a 1, a 2, a 3, and a 4 to get me from my 10s to my 40s. And then on the left-hand side, I've got a 0, comma, space, and a 4, comma, space, and a 5, because I have a 10, a 14, a 15, oops, and an 18 as well. So I'm going to hit my comma space again, and an 8 right there. On my 20s range, I've got my least 20 is going to be 22, followed by 3 25s, 1, 2, 3, oops, I need to get rid of one of those 2's there, don't I? And I believe that's going to be all of my 20s. On my 30s, I've got a 30, I've got a, looks like a 35, And then on my 40s range, I've got a 40 and a 44. I believe that is going to be it. Check my answer. Oh, we're missing something in my 20s. 22, 25, 25, and 25. Oh, that's because of that extra comma right there. That's why. Now everything checks. Also makes you note that the key is here. If you do not put your key on your stem and leaf plot on your test, I'm going to take some points off for it. So make sure you're doing that. Example 2 takes our study of stem and leaf plots a little bit further. And if you look at the key they have right here, they said 35 bar 6 equals 356 miles. So that was the case. Then this one right here, this would be 340, 341, 348, down here 367. Really simple. You just got to be able to look at the key, and the key is going to tell you exactly what the data values are that you're looking at and how they're going to end up working. So what kind of information can we get out of this? First off, since the longest distance traveled, that's going to be this one right here, 367. The range of the miles is going to be the 367 minus the 340, also known as 27 miles. The data value that occurs the most are going to be 340, 358, and 361, because you can see 340 occurs twice, 358 occurs twice, and 361 occurs twice. So remember, we call the one that occurs the most often the mode, and then the least data values that occur is going to end up being, let's see, that's going to be the 350 to 359 range, because there was only 3 of them, while there was 5 of them in the 340 range, and there was 5 of them in the 360 range. So there you go. That is some good examples of how you can use a stem and leaf plot to interpret your data. We're going to finish up our study of stem and leaf plot by you pausing the video and answering the questions that are on the slide for extra example number 2. Did it work good for you? Let's take a look at what I'm going to do. First thing I want to do is I want to look at my key right here. My key tells me that 1 bar 6 is equal to 16 years of age. So from now out here, I can see the youngest family member is going to be 01, which is going to be just 1 year of age. The oldest family member is going to be 65, which is going to be 65 years of age. And the range is going to be 65 minus 1, also known as 64 years of age. The most common age, that is going to be right here. That one occurs the most. It is the mode, and that's going to be 36. So we're going to take, the most common group is going to be still the 30 to 39 age group, because they occur more so often. And I guess the next common group would end up being, I'm a little confused by that. I'm sorry, there are no family members that are aged, okay, here we go. There's no family members that are aged, I totally misread that, 20 to 29, and there's no family members that are in the age group of 50 to 59. Check those answers, and there you go. There was a most common age. I did have it. Now we'll get everything correct. That's all there is to doing this. Stem and leaf plots are really simple. They're very useful tools in analyzing data, but they're not something you're going to see a lot out in the real world. Go ahead and get started on your homework. I'll answer any questions you have tomorrow.